Today's topic is disturbances in acid-base balance. We know the normal blood pH is 7.4 and it is normally maintained between the narrow range, that is 7.35 to 7.45, and if it goes beyond these limits, that results in various problems. And we know if it goes below the 6.8 or above the 7.8, that results in death also. So it's life-threatening also. So we can have a look on these things, that is what are called reasons results in the acid-base disturbance, or what are the reasons that causes the acidosis or alkalosis. Our body cells can tolerate only changes in the narrow ranges of pH. That is, if one pH unit is altered, if there is an alteration of 1 unit of pH, that results in the tenfold increase of H plus ion concentration. So that's why we can say that is body cells can tolerate only narrow ranges of this pH. And we know that is if it is between 7.38 to 7.42, there will be no problem. But if it goes below the 7.38 or if it goes below the 7.35, that is we can say if it is between 6.8 and 7.35, that is the condition known as acidosis. And if it goes above the 7.45, that is 7.45 to 7.8, that condition is alkalosis. And again, if it goes beyond this, that is if it goes above 7.8, that results in death. And also if the value goes below 6.8, that also results in the death. So we have to maintain this range, that is 7.42 to 7.38 to 7.42, that range it is okay. Now coming to this acidosis. So we can deal with acidosis and alkalosis, all these things in this topic. Coming to acidosis, we know acidosis from the name itself, it is too much acid. If there is too much acid or too little base, that results in the acidosis. And again we know if the acid increases, there will be decrease in pH of blood. So increase in acid or decrease in base, which results in the decrease in pH of blood. That is the condition known as acidosis. And again moving to the clinical state, alkalosis. In alkalosis we can see too much base or too much alkali or too little acid. And again this results in the increase in blood pH. So alkalosis is the condition where there is increased alkali or increased base or too little acid, which results in the increase in blood pH. Now moving to the different types of this acidosis, we can see there are two types, that is metabolic acidosis and respiratory acidosis. And in both these conditions, the metabolic acidosis and also in respiratory acidosis, we can see decrease in pH. Moving to alkalosis, also we can see similar, that is respiratory alkalosis and also metabolic alkalosis. There we can see increase in pH. So we can deal this with one by one, that is metabolic acidosis, respiratory acidosis, again metabolic alkalosis and respiratory alkalosis. Before that, we have to know about euphemia. Euphemia, it is the condition in which pH is within normal limit. So look at this thing. Here I have drawn one weight balance, and so when these values are within normal limit, then the pH will be also normal. See, that is if partial pressure carbon dioxide is 40 and carbonic acid, that is 40 millimeters of mercury, and if it is carbonic acid value, it is 1.2 millimoles per liter, and the bicarbonate value, if it is 24 millimoles per liter, then we can see that is pH is normal, that is 7.4. So when we look at this weighing balance, we can see pH become normal, that is 7.4, only when these values, that is if it is PCO2, partial pressure carbon dioxide is 40 millimeters of mercury, and carbonic acid value it is 1.2 millimoles per liter, bicarbonate value it is 24 millimoles per liter. And I already told you, we can calculate this one carbonic acid value by multiplying partial pressure of carbon dioxide into solubility part of the carbon dioxide, that is 0.3. So that is euphemia, that means normal blood pH, and these values are all, that is these levels are normal, that is bicarbonate level, carbonic acid level, partial pressure carbon dioxide level, all these are within normal level. So if any of this pH controlling mechanism get disturbed, our body has its own mechanism to maintain or to bring back all these altered values to normal range, and that is the compensatory mechanism. So if any of this alteration occurs, our body itself it will try its part to bring back all these values or bring back the normal pH. And we can divide this compensatory mechanism as fully compensated mechanism, partially compensated mechanism, and uncompensated mechanisms. If the alteration in pH is caused by metabolic or renal mechanism, or if the reason is metabolic or renal, then the compensation is by respiratory mechanism, and vice versa. That is, if the cause is by respiratory means, then the compensation by kidneys. And again, this respiratory compensation, that is immediate, but it is partial only. And we have seen three types of partial, compensation, complete compensation, and uncompensation mechanism. And when we move to the kidneys, it is if the process is slow but the compensation is complete, almost complete. And again, there is uncompensated mechanism also that has to be corrected by the cause, and we can go for the permanent correction also. So that's about this compensatory mechanism. And again, what is the main purpose? We have already seen in the buffers, that is, if the ratio of bicarbonate to carbonic acid is 20:1. I already discussed that in our class related to the buffers and all. There we have seen that if the bicarbonate to carbonic acid ratio is 20:1, then pH is maintained normally. And so here we can see two different types, that is metabolic and respiratory causes. And we can divide this acidosis into metabolic acidosis and respiratory acidosis, like that. Alkalosis into metabolic alkalosis and respiratory alkalosis. Moving to this acidosis, we know the pH is decreased, and metabolic acidosis, we can see low bicarbonate. So the bicarbonate value goes below this 24 millimoles per liter. Or we can see by the respiratory acidosis, there also we can see the pH value is decreased, but it is related to some respiratory cause, where the partial pressure of carbon dioxide is high, or carbonic acid value will be high, that is more than 1.2 millimoles per liter. So you have to remember these things, that is, if acidosis, we know in acidosis there will be too much acid or little base. So base, that part is related to metabolic acidosis, and the acid part, that is related to respiratory part. So to little base, that is metabolic. So little base means decreased bicarbonate. Too much acid means that is respiratory acidosis, and there we can see increased partial pressure of carbon dioxide or increased carbonic acid value also. Now moving to this alkalosis. Alkalosis, we know that is increased pH due to too much alkali or too little base. So base part, that moves to the metabolic alkalosis, that is increased bicarbonate, and the acid part, that moves to the respiratory alkalosis, that is little alkali, that means little acid, that means carbonic acid value is less, and also partial pressure carbon dioxide also less here. So we have to think and write these things. That is alkalosis and acidosis. We know too much acid, that is respiratory. Little base, that is metabolic acidosis. And coming to this alkalosis, there also we can say alkalosis increased pH, and too much alkali and decreased acid. So if alkali increase, that is bicarbonate increase, that is metabolic alkalosis. And if acid is decreased, that is respiratory alkalosis. So that's about the metabolic acidosis, respiratory acidosis. Metabolic alkalosis and respiratory alkalosis. And coming to this metabolic acidosis, we know acidosis means pH is decreased below 3.8, and we have already discussed all those things. And this, if pH is decreased below 7.38 means that may be due to two reasons. One is primary, that may be due to deficiency in the bicarbonate, and there is secondary reason, that is due to increased production of acid. So in this metabolic cause, we know it is primarily depends on the bicarbonate value. So metabolic acidosis mainly due to deficiency of bicarbonate, mainly that because metabolic, and also we can see increased production of acid also. Anyway, we can move to this, that is primary deficiency of this bicarbonate. So when we draw this weight balance, it looks like this. that is primary deficiency of bicarbonate. So bicarbonate value that is decreased from 24 to 12, that is almost half. So that's what happens in the metabolic acidosis. So metabolic related to base. So too little base here. Bicarbonate value is 12 millimoles per liter. And what happens to this partial pressure carbon dioxide and carbonic acid? It is shown normally here, that is partial pressure carbon dioxide is PCO2 is 40 and H2CO3 is 1.2, that is normal here. And what happens to this needle? It goes below the 7.4, almost 7.38, below 7.38. So that is metabolic acidosis. So while you are drawing this weight balance, you must point this needle towards value that is 7.3, 7.2 like that. Because the value, the pH value is decreased here. It goes below the 7.38. And that condition is the metabolic acidosis here. And our body will have a compensatory mechanism. We have discussed this. What it will do? It will try to bring back these values, or try to maintain the normal value by increasing the rate of respiration here, that you have studied already. If the cause is metabolic or renal, then the compensation is by respiration. So here the cause is metabolic. Why? Because bicarbonate related to bicarbonate, decreased bicarbonate. So the compensation is by respiratory mechanism, that is by increasing the rate of respiration. So what happens? If these values also reduced, then the pH balance will be okay. See, so that's what happens here. So our body will try to increase the rate of respiration. So what happens means the value of this PCO2 and carbonic acid will get decreased. As a result, now see, as a result what happens means this bicarbonate to carbonic acid ratio comes back to 20 is to normal. When we calculate that. See what happens in this case, here the bicarbonate to carbonic acid ratio is only 10. When you calculate that bicarbonate to carbonic acid ratio, when you calculate, it will be only 10. That is 12 by 1.2. So we have to increase this ratio up to 20. 20 is to 1. We know the normal bicarbonate carbonic acid ratio is 20 is to 1. Then only the pH is maintained normally. So when these values also get reduced, then the ratio become increased. That is, it will reach us from 10 to 20. So how this weight balance look when this value is compensated, or when these values carbon dioxide and carbonic acid get reduced by increasing the rate of respiration. So what happens means it will be just like the normal balance. See, normal balance pointing 7.4. Here it is, partial pressure of carbon dioxide becomes, instead of 40 it reduced to 20, just half. And carbonic acid ratio also get reduced to 0.6. And bicarbonate ratio, that is 12, you see. So when these values also get reduced, that is partial pressure carbon dioxide and carbonic acid also get reduced or just half, then the weight balance points the normal pH 7.4. And again when we calculate the bicarbonate to carbonic acid ratio for this, we will get 20 is to 1. That is normal. That is 12 by 0.6. We will get 20. So that's how our body will do this compensatory mechanism. That is here by increasing rate of respiration, because the cause is metabolic. So that's about the metabolic acidosis. So coming to the causes of metabolic acidosis, we can say it may be due to high anion gap acidosis or normal anion gap acidosis. So what happens in the high anion gap acidosis? In high anion gap acidosis, this anion gap increases. Why? Because bicarbonate reabsorption will be decreased, or this bicarbonate will enter, or this will increase the buffering action of this bicarbonate, because there will be excess acid production. In order to neutralize that acid, this increased amount of bicarbonate is coming to this buffering action. So what happens? As a result, here the bicarbonate concentration is reduced. So it becomes like this. And the anion gap will be increased. And that is known as high anion gap. I repeat, diabetic ketoacidosis, starvation ketoacidosis, renal failure, lactic acidosis. In all these conditions, we can see these phenomena. High anion gap acidosis. Now coming to normal anion gap acidosis. Here what happens? Here the anion gap will be normal. So nothing happens to the anion gap. It is normal. But we can see a condition that is hyperchloremic acidosis here. That is, chloride concentration is increased. So again, we can write like this. Chloride concentration increases and that results in the decreased level of bicarbonate. If chloride concentration increases, means that bicarbonate level there decreases. So that is normal anion gap acidosis. So in normal anion gap is normal, but only the chloride condition or chloride level will be increased, thereby decreasing this what? Bicarbonate. So hyperchloremic acidosis, we can name it as. And again, coming to various causes for this normal anion gap acidosis, normally diarrhea and dysentery, we know, in that condition all these things are reduced. Sodium, potassium, all these essentials are decreased. And coming to this renal tubular acidosis or carbonic anhydrase inhibitor therapy or salicylate poisoning, in these conditions we can see the hyperchloremic acidosis. So in renal tubular acidosis, carbonic anhydrase, we know the enzyme, that carbonic anhydrase inhibitor therapy, in that condition also salicylate poisoning. All these conditions leads to hyperchloremic acidosis or normal anion gap acidosis. Okay. Now we can move to treatment. Treatment is nothing. We can give IV bicarbonate therapy or lactate solution can be given. This lactate that is converted to bicarbonate in the liver. And again, there will be correction for the cause also. In some conditions, if any of these conditions persists, first correct these causes. So these are the treatment or therapy we are preferring.